Okay, this is the lecture video for Pre-Calculus Appendix 3. In this lecture, we're going to be looking at polynomials and specifically the various operations that you can perform using polynomials. We start off with the definition of a polynomial. As you can see in this box, a sub n minus 1, etc. As you go down the line, those represent the coefficients. N and n minus 1, etc. represent the exponents or the powers on each of the terms. Whatever the highest power is, that represents the degree of the polynomial. So whatever the highest degree is, that is the overall degree of the polynomial. And the coefficient of that term represents the leading coefficient, or what we call the leading term. When you are looking at a consideration of whether an expression is a polynomial, really be careful about checking the powers or the exponents. Those powers cannot be negative, nor can they be fractional. And that is written down here. Typically, we write polynomials in standard form, so we list the terms from the highest degree all the way down to the lowest degree. We have specific names for polynomials. For a monomial, that's one term. It's a polynomial with one term. A binomial is a polynomial with two terms, and a trinomial is a polynomial with three terms. So we start off in the homework for this section trying to identify whether we are dealing with a polynomial or not. Here's the example 1. State whether the following expression is a polynomial. If it is, give the degree. If not, state why not. Okay, so in this particular term, in this particular expression, this is a polynomial. I am specifically looking at the powers on each of the terms. None of them are negative and none of them are fractional. So this is a polynomial. If it is, state the degree. The degree is whatever the highest power is. So this is actually a fifth degree trinomial. They're not asking you to name what kind of polynomial it is, but I'll go ahead and do that. This is fifth degree because that's the highest power, and it just happens to be a trinomial. We have names for any kind of polynomial that is either 1, 2, or 3 terms, as I stated up here. And then once you go beyond 3 terms, then it's just a polynomial with however many terms it has. You would just indicate how many terms it has. Okay, here. This particular problem is not, or particular expression is not a polynomial, and that's because you have a term with a negative power, and that is not permitted if it is to be a polynomial. For instance, this can actually be written like this. 5x squared minus 3, and this is actually x to the negative 9th. Anytime a power is occurring down in the denominator, it can be rewritten as a negative power. So because you have a negative power, this is not a polynomial. Okay, moving on to example 3. State whether the expression is a monomial. Monomial meaning one term. This is a monomial because when it is a binomial or bigger, you will see the terms separated by either plus or minus signs. This expression does not have any plus or minus signs separating this term from the next term. There is no next term. So this is a monomial. And the degree of this particular monomial is a mixture of these two terms. Whenever it has more than one variable in the term, you add up those powers. Just add those up so that the degree is 2 plus 5, which is 7th degree. So yes, this is a monomial. It's one term. And with regard to the question having to do with degree, it is 7th degree. Okay, example 4. Tell whether the expression is a polynomial. If it is, give its degree. If it is not, state why not. Okay, this actually is a polynomial because the thing that you are looking for is you're making sure that the powers on each of the terms, that they're not negative, nor can the powers be fractional. And that's only on the variables. Okay, you could write this as a fractional power, like for instance, this can be written as 2 to the 1/2. Square roots are written like this in power form, if you recall from the previous courses that you've taken. But that's okay to have a power that is fractional when it's the power on a number. It is not okay to have this kind of power on a variable. So as long as your variables don't have any powers that are negative or any powers that are fractional, this passes as a polynomial. So yes, this is a polynomial. And then as far as the degree goes, this would be third degree. Okay, make sure that I've answered everything here. Here they wanted to state whether it's a polynomial. Yes, it was a polynomial. In fact, I went on to give the specific type of name, specific type of polynomial that it was. And the highest degree gave us the highest power gave us the degree. So we answered both questions there. Here we were to state whether it was a polynomial. It was not a polynomial because of the negative exponent on this variable. Example 3, state whether it's a monomial. Yes, it is a monomial because it never went on to indicate a second or a third term. And the degree was a combination of those two. In example 4, this was a polynomial because the fractional power was on a number, not a variable. So yes, it was a polynomial, and the degree is the highest degreed variable. Okay, moving on to example 5. Example 5, we start to look at different operations that you can perform with polynomials. A lot of these are going to be secondhand to you. The issue will always be your factoring and your foiling ability. So that's what we'll practice on the most. These will be pretty simple to you though. Okay, you're just adding like terms here. So here, there's only one squared term. We have two different linear terms, both positive, because this positive in front of the second parenthesis doesn't change any of these signs, so it's positive 2x and positive 2x combined to give you positive 4x. Then we're going to combine the constants, which are 7 and negative 2, to give us 5. Okay, moving on to example 6. Here you're going to be distributing the 2 to each of the terms inside this parenthesis. Here you're going to be distributing negative 3 to each of these terms, and then you're going to be combining like terms. So let's start all of that. So 2 times x cubed, 2x cubed, 2 times x squared, 2x squared, 2 times negative 5, negative 10. Then negative 3 times 3x cubed would be negative 9x cubed for this product right here. And then negative 3 times negative 2x squared would be positive 6x squared. Then look for any like terms that you might have. We only have one cubed term. We have, oh, actually we have another one down here. So let me fix that. We have 2 and negative 9. So 2 combined with negative 9 is negative 7. Okay, so we've combined those two. And then on the square terms, we have positive 2 and positive 6, which would be positive 8. So those are combined. And then we have one constant, which is negative 10, which gives us the final answer of negative 7x cubed plus 8x squared minus 10. Okay, then we start to get into the foiling. And here you're just foiling two binomials. There is no shortcut for this. For many of them, there are, not many of them, but there are a fair number of shortcuts for certain types of problems. This is not one of them. So you have to do just first times first. What FOIL stands for? Outer times outer, inner times inner, last times last. That's what foiling stands for. Okay, so following these arrows, short then long. So the upward arrows are 4x times x, which is 4x squared. Then 4x times 5 is 20x. Then following these upside down arrows, short one first, 3 times x is 3x, and 3 times 5 is 15, and then combine like terms as you have in all the previous problems. So we have one squared term, we have two linear terms, and when we combine those we get 23, and then we have a constant of 15, giving us a final answer of 4x squared plus 23x plus 15. In problem number 8, there is actually a shortcut for this, and I've given you that special shortcut. They're called special products. And it says whenever you are multiplying conjugates, these are called conjugates if you recall from previous experience with this type of problem. And all you do to avoid doing all of these steps that you did when you were foiling, there's 5 steps there. You got to do the 4 products, which are what those 4 arrows are about, and then you got to combine like terms. Well, you're going to go from 5 steps to 2 steps by understanding this shortcut. This just says that term that is in the front of each parenthesis, you square that. That's what this means right here. And the term that's in the back of each of the parentheses, you square that also. And then you throw a minus sign in between the 2 squares. So this is the shortcut for multiplying conjugates, and that's what you have here. So the term that's in the front of both parentheses is 5x. You're going to square that. And the term that's in the back of both of these parentheses is 3. You're going to square that. You just square the front term, square the back term. You could either be looking here or here. It really doesn't matter. And throw a minus in there. When you square this term, it's 25x squared, because that square applies to this as well as this. And when you square the 3, you get a 9. And there's your final answer, 25x squared minus 9, but with a lot less steps than this. Know the shortcuts, because at this point you've had a few classes where they've been introduced and then reintroduced, so it's time to start, doing things that are going to cut down on the steps. Okay, for this one, this is a binomial that's being squared, and there is a shortcut for that as well. It is this. You are going to square, you're going to double the product of these two things. First, you're going to square the front term, then you're going to multiply these two, but double it. So I could say double the product. That's what that means right there. And then you're going to take that back term and square it. The way the signs go is that both of the squares, the square in the front and the square in the back, they're both going to be positive because you can't square and get a negative. So the square in the front and the square in the back will both be positive. And then this middle term, which comes from multiplying these two terms and then doubling the coefficient, that will have the sign that's inside the parentheses. So that will match that. So if this is a negative, this will be a negative. If it's a plus, it'll be a plus. Okay, let's apply that. Okay, we're going to square, double, square. But remember, you're doubling the product. Okay, so when you square this, you're squaring the 7 as well as the x. So that's 49x squared. Okay, when you double the product, you have to do the product first. So 7x times 3 would be 21x. That's just doing the product. 7x times 3 is 21x, but then double that coefficient. Do nothing to the variable. Keep it in its first degree form as it was when you did the product. Just double the coefficient. Okay, so we've done the square, we've done the doubling part, and now we're going to do the other square, which is to square the back number. Put the signs in. Both of these terms that came from squaring will both be positive. As I stated earlier, you can't square and get a negative, so these are both positive. You don't need to put a positive in front of the first term. It's taken to be a positive. And then this term will have whatever sign is inside the parenthesis. So there you go. Foiling without the 5 steps. Okay, then here we're going, this one, some students are not very familiar with this particular shortcut, but it does cut down on the work because you could multiply, FOIL out 2 of these at a time and then drag in the third one, but that's quite a bit more work. If I have room here, I'll try to do it both ways just so you can see that you get the same answer either way. Okay, so here is the shortcut right here. It says to cube the first term. Then it says to multiply these two, where this is a number and this is the variable. You're going to multiply the number times the variable, both here and here. Number times the variable. For this first product, which is going to have a coefficient of 3, you're also going to take that product of this times this and multiply by 3, both in this term and in this term. But the square changes position. The first time, for this first product, the square will be on the variable, and for this second product, it'll be on the constant. Sorry about that, because this is a variable and this is a constant. So same thing here. Okay, you're just going to switch the power from the back on the variable to the front on the constant when you go from this term to this term. And then this last term you get by cubing this constant back here. Okay, so let's try that here. Okay, using this shortcut right here, okay, it says to cube the front term. So this is the front term. You're going to cube that. Okay, then you're going to go -3 times the constant times the variable. The constant is 4 and the variable is x. Okay, and the square, when you do it the first time, is on the variable. And then you switch to a positive. By the way, these terms switch in sign. They go from positive to negative to positive to negative. So we did positive, negative, positive now. And then this third term, it's pretty much just like this, only the second degree is going to switch from the back to the front on this term right here. So it's 3, just like you had a 3 here. And then you're going to have the constant times the variable. Constant times the variable, just like you had here, but instead of the square being here, it's going to switch up here to the constant. So it changes positions. And then that last term is negative. Again, the terms go positive, negative, and you're going to be cubing that constant for the last term. So it says this shortcut. Okay, then clean up these terms. Multiply them out where possible. Okay, this is 3 times 4, -12 x squared. Then this is 16 times 3 is 48. You can always put that in your calculator if you want. That's 16 times 3, 48. And then 4 cubed is 4 times 4 times 4, which is 64. Again, you can put that in your calculator if you want. And that's it. So x minus 4 all FOILed out is x cubed minus 12x squared plus 48x minus 64. The longer way to do it would be if you didn't know this shortcut. I'm just going to do it like that just so you can see that the answer is the same as this. So x minus 4 cubed is the same thing as this. And you could do it 2 at a time and then drag the third one in. So if you multiplied these two, it would be x squared minus 4x minus another 4x. You know, you'd be doing the standard foiling where you go this times this times this, then inner times inner, and last times last. So there'd be another 4x here when you do this upside down arrow. And then -4 times -4 would be 16. And then you'd want to combine like terms, the -4x and the -4x, which is negative 8x, whoops, close the parenthesis too soon, and then positive 16, but that was only x minus 4 to the second degree. We've got to drag in this third one. So you see it's already gotten quite monotonous and a lot more steps. You still have to multiply this times all of this. That would call for an extended type of FOILing because you're doing 2 terms multiplied by 3 terms. So go from the shorter one to the longer one so that your arrows don't overlap. So it's x times x squared, x times negative 8x, and x times 16. That would be 3 of the products. And you're going to have 6 of them. And then after using the x on all 3 of these in the form of a product, then you're going to go negative 4 times all 3 of these. Negative 4 times x squared, negative 4 times negative 8x, and negative 4 times 16. Now, I don't know if I have room for all this, but here we go. I'm going to do the arrows at the top first, then the products at the bottom last. Okay, there's 3 products each time. So it was x times x squared, that's x cubed, and then x times negative 8x, that's negative 8x squared. Then x times 16 is 16x. Then you're using negative 4 times each of these 3 items. So negative 4 times x squared is negative 4x squared. And then negative 4 times negative 8x is positive 32x. Then last product, negative 4 times 16 is negative 64. You can use your calculator for as much or as little of that as you want. Now you still, after doing all that, have to combine like terms. So it would be x cubed, then the x squared terms are negative 8 and negative 4. Combined together would be negative 12. And then you have 16x and 32x, which combined would be 48x. And then negative 64. So you can see that you get the same answer as if you knew the shortcut. So please learn the shortcuts because it's going to really cut down on the work. Okay, moving on to example 11. Okay, in number 11, you start to see some division problems. We're going to do short division and long division. When your divisor is a single term, you can do short division. In other words, just set up little mini fractions and reduce each one. That's what short division is. Okay, so this would be all of this, each term divided by 5x squared. And you don't need to write the 5x squared 3 times. But it is the divisor for each of these 3 terms. So if you want to write them separately, you can. It would look like this. It would be 15x to the 4th over 5x squared. Then the minus sign. Then it would be 20x cubed divided by 5x squared. And then it would be negative 10x divided by 5x squared. So if you were going to, write it like as 3 separate fractions rather than just using the 5x squared once, that's up to you. Okay, and then just try to remember that when you're doing division with like bases, it's the top power minus the bottom power. This you reduce it as you normally would. 15 divided by 5 is 3. This power minus this power is, so subtract top power minus bottom power. Oops. Okay, so 4 take away 2 would be 2 on that term, on the first term. 20 divided by 5 would be 4. Top power minus bottom power is x. And then 10 divided by 5 is 2. And then here you have 1 take away 2 on your x's. When you do 1 take away 2, you get x to the negative 1. And because you get x to the negative 1, that means that that x belongs in the denominator. anything with a negative power means it really belongs in the denominator. And once you do drag it to the denominator, then that power becomes positive, and you are expected to write it like that. So the final answer is 3x squared minus 4x minus 2 over x. You don't need to put the 1. If it was anything other than 1, then yes, you would have to put it there, but it's optional when it's a 1, as you well know. Example 12, different kind of division, and that's because instead of the divisor being a monomial, it's a binomial. And once you get into that, specifically when the variable is higher than first degree, you have to get into long division, because if it was only first degree, I could do synthetic division with you, which we will use quite a bit. Okay, but for this one, anything that's more than one term, higher than first degree, is going to be long division. Okay, so if you don't remember that, here it is, which you probably don't, because it is not stressed very heavily, although there are, there's problems in one of the sections in MAC 1105, but it's more, we concentrate more heavily on synthetic division in that course. So we're going to do it again because it is needed for particular types of problems in this class. Okay, so when you're doing long division, you're going to put your dividend inside this division box. And then you're going to put your divisor on the outside. Okay, and then we have to check this dividend. We have to make sure that there are no missing powers, which I should have done beforehand. But do you see that this skips from 4th degree to 2nd degree? And when that's the case, we need what's called a dummy variable or a placeholder. You can't just skip from 4th degree to 2nd degree. So what I'm going to do is I'm going to insert a placeholder, because as you're doing the division process, you are going to get some 3rd degree terms, and you need a column for them to line up with. So as far as 3rd degree terms, in this polynomial, there were 0 of them. So be looking for that before you actually put it in the box, unlike what I just did. I'll save you a little bit of time. And if you are missing any of the powers going from the highest power all the way down to the constant, then you should insert a placeholder for that particular degree. So we have 4th degree, 3rd degree, 2nd degree, 1st degree, 0 degree. The constant is considered 0 degree. We're dividing by x squared plus 6, and if you don't remember this procedure, I'm going to go over the 3 steps that you're going to repeat until you can't go any further. Okay, so what happens in this particular type of division, let me just move this over a little bit, is you're going to be concentrating on this term right here, this variable right here. And you're going to ask yourself, what can I multiply this by in order to turn it into the leftmost term in the dividend? What do I multiply this by to turn it into this? That's all you're asking yourself. You're always concentrating on, what do I multiply this by to create the leftmost term, which is just this term right now. So what you would multiply this by is 4, and you would need a couple of more x's to turn it into that. So you'd be multiplying by 4x squared. Once you come up with that, you're going to use it. You're going to multiply each of the terms in the divisor by what you have come up with. You have actually come up with the first term of the answer, of the quotient. This is called the quotient. This is called the dividend. Your answer is called the quotient. I have just started a 3-step process. What do I multiply that by to turn it into that? 4x squared. Now use this as a multiplier for each of the terms in the divisor. 4x squared times x squared, 4x to the 4th. 4x squared times 6, 24, and make sure that you're lining it up properly. Look what I'm going to get right now. 4x squared times 6 is 24x squared. You want to put that product that you're going to get right now in the x squared column. So nothing right here. And you're going to put the 24. And you don't have to really put anything there. You can just leave that space blank. It looks a little bit nicer that way. Okay, so then this is going to be 24x squared. And then as soon as you get done using this term to multiply by everything in the divisor, then it's time to subtract. So I came up with this term, that was step 1. Then I used it as a multiplier, and now I'm going to go through the subtraction step where you're subtracting this whole bottom row. And if you're subtracting one polynomial from the polynomial that's on top of it, all you do is switch the sign. So take each of these terms, the signs that they presently have, and switch each one. And you might want to circle your switch signs so that you pay attention to those as you combine them with the terms above. So it's 4x to the 4th minus 4x to the 4th, so that's gone. Hold on for 1 second. And then there's nothing here, but you can go ahead and bring it down. And when you put this placeholder, and you can use a minus or a plus, it actually doesn't matter. I'm just going to put a plus there. So bring that term down just in case we get an x cubed term this time. Negative 8 combined with negative 24 is negative 32. On your x squared term, bring down that 4x, bring down the 4, and go again. Okay, so again, always trying to ask yourself, what do I multiply this by to turn it into the leftmost term here? Okay, so what are you going to multiply by to create this? You really don't have any x cubed terms, so even if you were to multiply this by x to create x cubed, it would have to be 0x cubed in order to create this, so you really don't need to worry about that term. Because no matter what you multiply this by, you're not going to get 0x cubed. So you can move on to the next term. So now the question is, what do I multiply this by in order to create negative 32x squared? And it would be negative 32. Then negative 32 times x squared would be negative 32x squared. And then negative 32 times 6 would be negative 192. And I have to put it under this constant right here. You always have to line them up with the degree that they belong with. So negative 32 times x squared is this. Negative 32 times 6 is negative 192. Place it under the constant column, and then go through the subtraction phase where you switch each of these signs and combine them with what's above it. So this would be canceled. Negative 32x squared plus 32x squared, those cancel. Drop down the 4x. And then 4 plus 192 would be 196. Okay, then this, there's no way to multiply x squared to turn it into a power that's less than this. So when the power down here is less than this one, that means that you cannot go any further. So that's when it's time to stop and report your answer. So your answer here is my quotient is 4x squared minus 32 with a remainder of 4x, let me write it down here, plus 196. And most often your remainder is written as a fraction. It'll be written as what's left over the divisor. Those are very long. Well, I guess that's why they're called long division. Okay, let me stop for just 1 minute. Let's get a sip of something. Okay, let's move on to factoring polynomials. Okay, so in number 13, you're going to be factoring the difference of squares. That's what this is. And you're going to break it down into, they're giving you the formula right here. You take the square root of this term, and you're going to place it in the front of each parenthesis. So square root, and then you're going to take the square root of the second term. This is also a square root. Okay, so following that particular format, let's work with this. All right, now when you're factoring, you always want to make sure that before you use any kind of special factoring formula, that you take out anything that is a common factor. Always want to factor out the greatest common factor first. And so it says in the directions, factor out the GCF first, then use the formula for factoring the difference of squares, which I've given you right here. So notice that 2 goes into both of these. This is the same thing as 2 times 25 minus 49x squared, which if you hadn't taken out the 2, then you would not have things that you can take the square root of. According to this, when you go and factor this, you're going to have your 2. Then when you factor the difference of 2 squares, you're going to have 2 parentheses, one with a minus, one with a plus, doesn't matter which one you put first. And it's all about just taking the square roots. Square root of this is 5. It goes there as well as there. Square root of the back term is 7x, and that goes in the back of each parenthesis. And that's it. That's a pretty short formula, pretty easy to remember. Then we get into factoring trinomials. This is a trinomial, and there's a specific, this can be taught different ways, but this is a pretty typical way to look at it. An algorithm that's used for factoring this type of problem is that you're going to have 2 parentheses when you get done factoring. In order to fill in the front position of each one, you just ask yourself, what's the square root of this first term? Now this works when the coefficient is 1, because it's a more involved process when this is anything bigger than 1. So when the coefficient is 1 on a trinomial like this, just take the square root of that front term. That'll fill in the front position of each of these. And then to fill in the back values or expressions, you have to find 2 numbers that multiply to give you the C value. And as well as and the 2 numbers that multiply to give you the C value, you also should be able to add them to get the B value, which in this case is -8. Okay, so you start by considering this, asking yourself, what are some things that divide into 65? Okay, so if it ends in a 5, 5 goes into it. So you can just kind of mess around with your calculator. 65 divided by 5. Okay, so 13 times 5 is 65. Notice that the difference between those 2 things is 8. So that's perfect right there. You're going to use a 5 and a 13. So you start off by thinking of things that divide into this, because those will help you find the product pairs that you need. Okay, so now one of these has to be negative. We know that we're going to use a 5 and a 13 to go ahead and get that 65, but notice how when you add them, you want it to come out negative. Therefore, the bigger of these 2 numbers has to be negative. Let me scoot this over a little bit. That's going to be negative. So that times that is -65. And then 5 plus -13 is -8. So once you find the two numbers that multiply to give you the C value, but also add to give you the middle value, and you should definitely check that the signs are right, then you toss them into the back position of each of these parentheses. It doesn't matter which one you give first. You can put the positive 5 first and then the negative 13 or vice versa. And there it is, all factored. Okay, moving to 15, factor out the GCF, then use the algorithm given in number 13. I don't know if that's the algorithm in number 13. Okay, so let's see. We're going to take out the 2 first, and that'll be x squared minus 2x minus 15. Okay, so 2x squared minus 4x, so this is 2x squared minus 4x minus 30. All I did was factor out the GCF, and you're going to factor a trinomial here just like we factored a trinomial here. So this actually should say use the algorithm given in 14 to fix that. Okay, so just like we did in number 14, I'm looking for two numbers that multiply together to give me the C value. But when added together, those same two values, this is the C value, those same two values should give me the B value, which is -2. Okay, and so that's pretty easy. It's going to be 5 times 3 is 15, and if one of them is negative and one of them is positive, the difference between 5 and 3 is 2. Okay, so we know we're going to use 5 and 3. One of them has to be negative. So if you're trying to get a negative when you add the two numbers, then the bigger number has to be negative, which would be the 5. That's typically what students get wrong the most often, is they put the negative on the wrong one, cause themselves to get the answer wrong. So make sure that you are checking both of these steps before giving them the final answer. So we factored out a 2, then we had 2 parentheses. X is in the front. In other words, square root of this is x, so x goes there, and then we found the numbers that go in the back. Okay, so just practicing what we did in example 14, only this one had a GCF that you had to take out first. Always take out the GCF out first. Okay, moving to example 16. There's a lot in here because you're reviewing everything from the previous course. Okay, notice that here we have a trinomial, but you no longer have a 1 here, and that involves a more advanced technique. I'm going to use the technique called splitting the middle term. Okay, so in this one, you start by, again, looking for the product of two numbers that's equal to not just the C value this time, but A times C. So this is your A value. Remember, this is called the B value, like when you were learning the quadratic formula. This was called A, B, and this is called C. So this time you're looking for two numbers that multiply together to give you whatever A times C is. A times C is 90. 15 times 6 is 90. So you're looking for two numbers that multiply together to give you 90. Let me write this a little bit more clearly. Going for a 90 here. And this is your A times C value. But you also need to, whatever you come up with as the numbers that should be multiplied to give you 90, you should also be able to add those numbers to give you the B value, which is the one in the middle. Okay, that would be 9 times 10 is 19, and when you add 10 and 9, you're going to get 19, but you have to put negatives on both of them. Negative 10 times negative 9 is 90, and negative 10 plus negative 9 is 19. So those are the numbers. So in this technique called splitting the middle term, you are going to copy the first term, but instead of writing a negative 19x for your middle term, you're going to split up that negative 19 using these numbers, but with x's on them. So I'm going to go negative 10x. I use the negative 10, and then I'm also going to use the negative 9. Just put x's on them because these two terms represent just a different way to write negative 19x. And then copy that last term. You've now stretched out this polynomial from 3 terms to 4 terms, which makes it ready for factor by grouping. So you finish using factor by grouping. Okay, so here we go. If you recall, factor by grouping, you group 2 at a time and take out the common term. You're actually going to take out a GCF 3 times when you're doing factor by grouping. What these two have in common is 5x. So take out that GCF for the first 2 terms and then ask yourself, what do I have to multiply this GCF by to get back each of these terms? So 5x times 3x would give you this 15x squared back again, and then 5x times negative 2 would give you the negative 10x. Then go to the back and take out the GCF for the back 2 terms. So what's common to both of these? And remember, what you get in this parenthesis should match this in order for you to continue using factor by grouping. So I'm going to take out a negative 3 because then what's in here, if I take out a negative 3 as opposed to positive 3, what's in here will match this, and it needs to. So negative 3 times 3x is negative 9x, and negative 3 times, times negative 2, negative 3 times negative 2 is positive 6. And in that way, these two match. So you can take out a GCF actually one more time. Because at this point, once you take out the GCF for the front 2 terms and the GCF out for the back 2 terms, you can look at this as 2 separate terms. This term and this term have the 3x minus 2 in common, so you can take that out as the common factor that belongs to both this term and this term. And then what goes in the other parentheses is 5x minus 3. And it actually doesn't matter whether you have this first or this first. And that is the finale of that problem. So, factoring a trinomial when the leading coefficient is bigger than 1. It's called splitting the middle term. Okay, we're going to do it one more time. But in this problem, there's actually a GCF that can be taken out first. Always do that first. There wasn't one in this problem. There was no number that went into 15, 19, and 6. Now, I've clued you in about when to take out the GCF, but you're going to have to recognize it yourself. So try to train yourself to look at everything in the polynomial and see if there's anything that's common to all the terms, and then go into whatever additional factoring method applies at that point. So in this particular problem, 2 goes into all of these. So this will be equal to 2 times 9x squared, and then 2 times 18. 2 times 18 is 36, and then 2 times 5 is 10. Okay, so this is what we're actually going to be splitting the middle term on. So we're going to be looking for 2 numbers. Let's go over the procedure again. We're looking for 2 numbers that multiply to give you A times C. This is the A, this is the C. So A times C is 45. There's your A times C value. So we'll be looking for 2 numbers that multiply to give you 45, but those same 2 numbers need to add to give you the B term. And the B term, okay, don't forget, this is A, this is B, this is C. The B term is 18. Okay, so start thinking of numbers you can multiply to get 15. 15 and 3, very common. even though it can also be 1 times 45, but 1 and 45 don't add up to 18. So it's 15 times 3. And then 15 plus 3, as you can see, also adds up to 18. When you find the numbers that satisfy both of these steps, then you're ready to go on to the next step. So we will now split the middle term using these numbers, 15 and 3. Okay, so here we go. We have the 2 out here. I'm just going to use brackets now since I already have a parenthesis. It's going to be 9x squared. And then instead of 18x, I'm going to have 15x plus 3x. You can use brackets or parentheses, it doesn't matter. And then I'm going to continue using factor by grouping. I'm just going to work on this right now. So what's common to both of those is 3x, and then it would be 3x plus 5 to get back each of those terms. 3x times 3x is 9x squared. 3x times 5 is 15x. And then group these two. They have nothing in common, and therefore the GCF, which always goes out front, is said to be 1 when they have nothing in common. And then what would you multiply a 1 by to get this back again? 3x plus 1. After you've taken the GCF out of the front two and the GCF out of the back two, then you look at this as two terms. This is one term, this is the second term. And what they have in common is the 3x plus 5. And then what would go in the other parenthesis are these GCFs that you pulled out, 3x plus 1. And then don't forget to drop down that 2. Should kind of drop it down each time just so you don't forget, but in the end, this is your final answer. Okay, almost there. So now we have something that once again has a GCF, and notice that y squared is common to all three of these terms. Every single one of these terms has at least y to the second degree as part of it. So we're going to take out y squared as the GCF, and always when you take out a GCF, there's one parenthesis next to the GCF that you've taken out. And you use that GCF as a multiplier to regain each of the original terms through multiplication. So in other words, y squared times what would give you y to the fourth? Y squared. Y squared times what would give you this term? 7y. This times this would be 7y cubed. And then y squared times what would give you that? Just 12. So what it turns out is that you've taken out a y squared and you still have to factor this, which will result in two parentheses. So this was like numbers 14 and where we had a trinomial and a leading coefficient of 1. We did that in problem number 14 and also in 15. And we're going to use that to continue this problem. So we're looking for two numbers that multiply to give you 12, but that add to give you 7. Okay, that's going to be 4 and 3. That'll work here as well as here, and therefore those are the numbers. Remember, just take the square root of the front term. That goes here and here, while these numbers that you came up with that work in both of these steps are the numbers that go in the back. Doesn't matter which one you put first. You could put the 3 here and then the 4 or vice versa. Okay, so that's taking out a GCF and then factoring the remaining trinomial that had a second degree trinomial which had a leading coefficient of 1, and we use this to get those back terms. Okay, and then Use the formula for factoring the difference of squares. This is the formula. We've already used it in a couple of other problems, and that can be done here. Anything where you have two terms separated by a minus, and you could take the square root of both of those terms is considered the difference of squares. These are just a little bit higher powered, and therefore we're going to have to use this procedure factoring the difference of squares more than once because of these higher powers. Okay. So this particular algorithm says that when you factor, you're going to have two parentheses. One will have a plus, one will have a minus, doesn't matter which one you put first. And to fill in the front spots, the front position, you take the square root of this term, of the first term. And if it's a higher power, basically you're just, anytime you take a square root, you're taking the power and dividing by 2 for a square root. If you were taking a cube root, you would take the power and divide by 3. So 4 divided by 2 is x squared. That goes there and there. It is the square root of x to the 4th. And then the square root of 256, you can just put that in your calculator. Unless you have it memorized, it's 16. And then in this problem, you can actually continue. The sum of squares cannot be factored further. You're done when it comes to this front factor. But this is the difference of squares, and therefore you can go further, just as this algorithm indicates. So there's two parentheses whenever you are factoring the difference of two squares. You take the square root of the first term, and it goes in the first position. You take the square root of the back term, it goes in the back position, and then you alternate those signs. Bring down this factor that couldn't be factored any further because it's part of the final answer, and all of this is your final answer. Whew, a lot in this section. Okay, so this is the last page. Okay, again, these things with the cubes, students tend to be less familiar with them, but it was covered in the last course, and we're going to continue using them here, but in more depth. Okay, so this says when you have the difference of cubes, that you use this algorithm to get it factored. And it could be the difference of cubes, or it could be the sum of cubes. Basically, what the algorithm says is that you're going to take the cube root of this term right here. That'll go in the front position. You're going to take the cube root of the back term. That goes in this back position. This first short parenthesis will only have two terms. And then you're going to use these two terms to generate the three terms in the second parenthesis. So once you get this term, you're going to, whatever this term turns out to be, you're going to square it to get the first term in the second parenthesis that has the three terms in it. Then you're going to multiply these two terms, and that's your middle term, and then you're going to square that back to them. So square, multiply, square. This is a square of this. This is the product. You're just multiplying the two terms that you got here, and then you're squaring again. These are just cube roots. You're taking the cube root of this first term, and then you're taking the cube root of the second term. Okay, so let's practice this. Now, since you're starting off with a problem that has parentheses, I'm going to use brackets to separate things. Okay, so this was a short pair of parentheses or a short pair of brackets that only has two items in it, and then we need a longer one that we can fit three items into. Okay, so following this, we're going to take the cube root of this first term. This is the first term. This is the second term. So the cube root of this term, just remove the cube. You want to take a cube root, take that power, divide by 3, which would give you a 1. It would be 4x minus 5 to a power of 1, or just 4x. Let's keep it in parentheses, though. And then the cube root of the second term is just 2. So I did exactly what this algorithm said. I took the cube root of the first term, and I took the cube root of the second term, and notice that the sign in the first parenthesis is the same as the original. So you should have a minus there. Okay, then I'm going to square, multiply, square using these two items that I got by taking cube roots. I'm going to square. I'm going to multiply these two things. And then I'm going to square again. Let me move this back a little bit. Don't have enough room here. Okay, so I did square, I did multiply, and then I'm going to take this back item and I'm going to square this. Okay, the signs. Notice that in this algorithm that you've been given here, that the first sign will match what was in the original, and then whatever this sign was, this will switch to the opposite. Likewise here. If you started off with a plus sign, then the first short parenthesis will have a plus sign, and this will always be these two will always be opposite. This last term is always positive, whether you start off with the difference of cubes or the sum of cubes. Okay, so if this was a minus, this is a plus, this term is always positive. And then the problem with this is it's not easy when you factor something like this that starts off with a parentheses, because you still have quite a bit of simplifying to do. So in this first bracket, you have 4x minus 5 minus 2, which is 4x minus 7. I'm combining the negative 5 with the negative 2. And then there's a lot more work to do in the second brackets. First of all, you have to know how to square, and it's really good to be using your shortcuts at this point. When you square a binomial, as instructed on one of the previous pages, it's square, double the product, and then square. So without me writing out 4x minus 5 times 4x minus 5 and all of the foiling arrows, I'm just going to use this shortcut because there's already a bunch of work in this problem. So square this. You square the 4 as well as the x. So it'll be 16x squared. So I squared. When you double, you multiply these two, which would be 20x, and then you double the 20. So multiply 4 times 5, 4x times 5 is 20. Forget the negative right now because we'll put the signs in as we go along. 4x times 5 is 20x, double that. The double of 20 is 40. Now square again. Square this 5, you're going to get 25. When you're using the square, double, square shortcut, the items that came from squaring, this and this, are both positive. And this will be the same sign as what was in the parenthesis. Okay, so that's all squared out. For this middle product, it's 2 times 4x is 8x. And then 2 times negative 5 is negative 10. And this last term that you see here is 4. Okay, once you no longer have parentheses inside the bracket, you can just shift over to parentheses, or you can leave it as brackets. But you still need to combine like terms there. I'm going to just go to parentheses now. So it's 4x minus 7 in the first pair of grouping symbols. And then back here, I have a 16x squared. And then as far as my linear terms, I have negative 40 and 8 is negative 32x. And as far as my constants go, 25, positive 25 minus 10 is 15. 15 plus 4 is 19. And that is the final answer. Okay, moving on to number 21. Factor the given polynomial completely. It's just grouping. Now we've already done this when I demonstrated the procedure called splitting the middle term, but this just starts off as factor by grouping, which is for 4 terms. Let's see if this works now. If we group the first 2 terms, what they have in common is x squared. Then you need a single parenthesis and ask yourself x squared times what gives you back each of these terms. To get back the x cubed, it would be multiplying by just x and multiplying by 3 to get the back term. Then move to the back two terms and ask yourself, what do they have in common? 16 divides into this as well as this. So take out negative 16, and then negative 16 times x is negative 16x, and negative 16 times positive 3 would give you negative 48. Then look at this as two terms. This is one term, this is one term. And what they have in common is the x plus 3. So take out that as the third and final GCF. And then what goes in the other pair of parentheses are the GCFs that you took out for the first two terms and the second two terms. So x squared minus 16. Then notice that once you get that far, you can still factor this right here. This is the difference of squares. That's what we mean by factor completely. Keep factoring until you can't factor anymore, which means you have to recognize when you can factor and when you can no longer factor any further. So this is going to be the x plus 3. That's out front, and then this is the difference of two squares, which when you factor it, this, it turns into two parentheses. You take the square root of the front term, which goes here and here. You take the square root of the back term, which goes in the back of each parenthesis, and alternate those signs. And that is the final completely factored answer. Okay, moving to 22. I wanted to refamiliarize you with perfect square trinomials. And so they give you a way to check this, but I think it's easier if I just show you how to check it from the problem. It'll be easier to understand. Okay, so you can see that this is a trinomial. And you could use splitting the middle term because there's nothing that all three of these have in common. So you can't factor out a GCF, so that's going to remain as a 4. And sometimes there's an easier way to factor it, as in the case of a perfect square trinomial. There's a much easier way to get it factored if you can recognize that it's a perfect square trinomial. So here's what this is all about. It's all about checking whether it's a perfect square trinomial. Try to take the square root of this term, which is 2x. Then try to take the square root of this term. Now, if you can't do this right from the get-go, you know it's not a perfect square trinomial. Take the square root. This will be the first square root. This will be the second one. Square root of this is 9. Multiply these two square roots, which gives you 18x. Then double it. And do you see that you get 36x? And if, after taking the square root of the front and the square root of the back, multiplying them, and then doubling it, if this term is what you see in the middle, that means that yes, this is a perfect square trinomial. So if you know how to check that it's a perfect square trinomial, you're also simultaneously factoring it. Because anything that is a perfect square trinomial factors like this. It always has a square right here. And the things that fill in the front as well as the back are these square roots that you took when you were checking it. So you would put a 2x here and a 9 here, and then use that sign on the middle term to connect them. This is a shortcut for factoring perfect square trinomials. Okay, moving to 23, determine the number that should be added to complete the square on the expression. So what you're doing here is you are creating a perfect square trinomial. You're not going to factor it. They just want to know what would be the number that you have to add right here in order to create a perfect square trinomial. Because see how when it was a perfect square trinomial, how you had a squared term, a specific type of linear term, and then a constant here. So you're coming up with that constant. And here are the steps for doing so. These are very easy. You go to this linear coefficient, you cut it in half. Another pencil, which is 8, and then you square it. Okay, so cut in half, then square it. So when they say, what do you have to add to this, to these two terms in order to create, to complete this, it's called completing the square, but you're really creating a perfect square trinomial. It's the same thing. Okay, so you'd have to add 64. What do you have to add? This number right here. Okay, maybe it's a little harder when there's a fraction, but you use the same two steps. You take this linear coefficient and cut it in half. Take that linear coefficient and cut it in half. When you take half of something, I mean, it's easy when you're taking half of an integer, but when you're taking half of a fraction, maybe you have to write it out. So when you're taking half of anything, you go 1/2 times the number you're trying to take half of. In the case of two fractions, which you have here, it's top times top, bottom times bottom. Okay, so this would be 1 times -1 over 10. Okay, don't forget that after you cut it in half, you still need to do the part where you square it, which is exactly what I did here. I took half of that linear coefficient, this one just happened to be a fraction, and then I squared it. So there's two steps to coming up with a number. Cut it in half, then square it. If you're going to square this, it is -1 squared, in other words, -1 times -1, and then 10 squared, which is 100. So what has to be added here to create, to complete the square, or in other words, to create a perfect square trinomial? Positive 1 over 100. It's always positive because you got that number by squaring it on the last step, and you can't square something and come out with a negative. Okay, that completes Appendix 3. And I'll come back at you with a video for the other appendix, which is Appendix 4.